All right, today we're going to be talking about something pretty important, and that is all about factoring polynomials. So take a second, pause your video, and I want you to try the Ignite at the top of the page. All right, so for this one, this is a pretty typical SAT question that you'll see. This says, how many solutions does the graph system have? So whether, in this case, they gave us a 3-equation system, if it has 2, 3, 4, the idea of a solution of that system is it's just talking about what are the points of intersection. But it's a point where all of them meet together. So in this case, out of all my 3 lines, the only point where they actually all meet together is this particular point right there. So for us, since there is only one point that they all meet at, it just means that we only have one solution. All right, now before we get into talking about factoring polynomials, first we have to talk about a few vocab words. The first of which is called a term. All right, so term, what exactly does it mean to be a term? Basically, terms are just separated by addition and subtraction signs. Or another way of thinking about it is that they're grouped by multiplication and division. So when we talk about terms, usually it's in reference to one of probably the 3 most common types of polynomials. We have what's called a monomial, a binomial, and a trinomial. And really these are talking about how many terms the polynomial actually has. So for example, a monomial is a 1-term polynomial. So in terms of terms, it basically just means that there are no addition or subtraction signs. So it could be something as complicated as like 3xy. Still, they're grouped, all of those pieces, the 3, the x, and the y, since they're being multiplied, they're grouped together, and that makes essentially just 1 term. A binomial means that we have 2 terms, and that basically just means that we're going to have at least one addition or we're going to have exactly one addition or subtraction sign. So x plus 1 is a good example of a binomial. It could be something like xy plus z, something like that. We could have xy, we could have minus x squared minus 7. Those are all great examples of binomials because they have one addition or subtraction sign. And last but not least, we have what's called a trinomial, and these are your 3-term polynomials. So a good example of this is probably like a classic quadratic that we just graphed last unit. X squared plus 3x plus 7. We have 2 addition signs, which means I have 3 separate terms. Now, we need those because we're going to talk about when we multiply polynomials. This obviously isn't factoring, but multiplying, you'll see, kind of ties into the whole factoring idea. And when we multiply, obviously we just did this last unit, so I'm going to do this part pretty quickly. But basically multiplying just means you're going to take each term in the first, and you're going to multiply it through to each term in the second. So x I have to multiply through to x and 10, and then -4 I have to multiply also to the x and 10. And then we combine like terms. So really that part of this obviously isn't new, but I really want you to focus on exactly what you just did. When we multiply, we took 2 binomials, we multiplied them together, and then we simplified. Factoring is the exact opposite of multiplying. What factoring does is, and this obviously you should have used in geometry, and it's definitely something we did in Unit 1, or in Algebra 1, excuse me. But the idea of factoring is that it looks at whatever the polynomial is, and it says, what are the 2 things that you multiplied to give you that polynomial? We do this a lot of times with numbers. Like if I ask you for factors of 10 are all the combos of numbers that could multiply to give you 10. When it comes to plain numbers, though, a lot of times there's multiple options. Like 10, I could do 1 and 10, or I could do 2 and 5. So that's one where I don't really know which one, or in that case, it could be either of those. Polynomials usually have 2 specific things. These right here are what we call, this guy and this guy, are what we call factors of the polynomial. If I take this and multiply it by this, you get our final answer, which was this. So when we go about reversing that process, you're going to notice this is the same exact problem that we solved up here, but we're going to go the opposite direction, because you're probably saying, well, how do we get from this Woo, that went crazy. How do we get from this and get it back into this form? Well, we have a process. And usually probably the process we're going to use the most is something called guess and check. And we really use it when the A value is 1. If the A value is not 1 or work, we have a little bit more work to do. But pretty much what we do is we always want to start every single factoring problem by choosing first and foremost the GCF. So finding the GCF is one way of factoring. And we do that by looking for every term in the problem. And we say, what's a number? What's the largest number or variables it could be that go into all of them? This one's a little odd in that 1, 6, and 40. The only number that really goes into all of them is 1. So no matter what factoring problem we throw at you, the first step is always going to be to take out the GCF. Now, if your GCF is 1, you're going to notice that not much changes. So where it's kind of, think of factoring kind of like as undistributing. That means here there wasn't really a number that I distributed through. But there has to be a way to kind of go through and break up this polynomial into its 2 respective factors. And how we do that is we start by looking at the last number. We say, okay, if I look at 40, I'm going to ignore signs for just a moment. If I look at 40, let's think about where that came from in the example above. If I look up here and I say, okay, well, if I look at that 40, well, 40 really came from one specific place. Ooh, sorry about that. If I looked at the 40, this 40 right here, well, that really came from when I multiplied these 2 pieces together. So whatever numbers I put here and here have to multiply to give me 40. Whatever I put, whatever goes in this spot, and this spot should be what multiplies to give me this guy right here, which usually that's the easiest part to tackle. Well, what gives me x squared? Well, x times x. Now the 40, this is where things get a little bit tricky because 40 has a lot of factors. We could do 1 times 40, 2 times 20, 4 times 10. We could do n 5 times 8. There really has to be a way for us to choose which combo it's going to be. And part of what we do for that is that's where the middle term comes into play. So we look at the last term and we say, really, we ask ourselves the question, well, what multiplies to give me negative 40? Obviously, we haven't tackled signs yet, I know, but your tell for which one it's going to be, we say, well, what adds to give me 6 or could add to give me 6? Like I'm looking at my numbers right now, 1 and 40, there is no combination of 1 and 40 that will ever get me to 6. Same thing with 2 and 20. If I take 2 plus 20, I get 22. If I do 20 minus 2, I get 18. Either way, not 6. You're going to notice that there's a winner in 4 and 10. Hopefully you're thinking that, well, if I do 10 minus 4, I get 6. And what's more than that, if I take negative 4 times 10, we get negative 40, which is what we're supposed to get in the first place. What that means is those are what I like to call the magic numbers. Those are the numbers that are going to go in those spots. And you're going to notice that's exactly what we had up here. That's what we were supposed to get. So factoring is kind of that step for how we go through and figure out, well, what were the 2 things that we multiplied? So if we look at example 3, you're going to notice that obviously it's not like I asked you to multiply these 2 factors together. But we start by factoring by first finding the GCF. And the largest number that goes into both 2, 6, and 36 is 2. Now, whatever your GCF is, we always start by dividing by that number. So I'm going to divide all of them by 2. GCF goes on the outside, and the remainders go back on the inside. So 2 divided by 2 cancels. We're left with just 1x squared. Negative 6 divided by 2 leaves us with a negative 3x. And negative 36 divided by 2 leaves us with a negative 18. So if we're going to go that extra step and actually figure out, well, what were the 2 quantities? Again, usually I start with this piece. Because whatever I put here and here has to multiply to give me x squared. And the only combinations of what would work has to be x times x. Whatever goes here and here have to multiply to give me a negative 18. So let's start off with, well, let's answer that question. What are all the numbers that could multiply to give me 18? Well, it could be 1 and 18. It could be 2 and 9. Or it could be 3 and 6. Now, keep in mind, at the end of the day, the sign does matter. Really, I'm looking for what multiplies to give me a negative 18. That also adds to give me a negative 3x. Whatever you choose, it really has to satisfy both this piece and this piece. Now, if I'm looking at this, we're saying, all right, well, the only numbers that even get me remotely close to 3 when I add or subtract them, it's really only 3 and 6. 1 and 18, that either puts me at 19 or 17. That doesn't work. 2 and 9 either puts me at 11 or 7, so that one also is out. Our only options are going to be 3 and 6. Now, the question is signs. If it multiplies to give me a negative 18, that just tells me that one of my numbers has to be negative. And in order to get a negative 3, that would mean the 6 would have to be negative. Now, in terms of answers, if you are saying, well, Ms. Hardy, could I switch those? Yeah. If you wrote your answer as x minus 6 times x plus 3, then actually either one of those answers would be a fantastic factored form. You can change up the order if you want. Typically, all the numbers are always written out in front. Okay? So what I want you guys to do, I want you guys to pause your video and I want you to try example 4. Okay, number 4. Now I paused number 4 mid-problem just because when you go through and look at this, you're probably noticing something odd happens. Because if you, obviously this one does have a GCF. So if I divide each of my terms by 3, the 3 goes on the outside and all the leftovers go back on the inside. So if I'm gonna go to my next step, the goal is to say, okay, well, starting off, the first question we have to ask is we have to say, okay, well, what multiplies to give me a negative 12? So obviously the negative is something we have to tackle, but first I just deal with which numbers can even get me to my middle term, because this is what they have to add to. So if I look at all my numbers, 1 and 12, that if I add or subtract those numbers, you can't get to 3. You either get 13 or you get 11, can't ever get 3. Same thing with 6 and 2. 6 and 2 can get you kind of close. They can get you down to 4 somehow, or potentially up to 8, but again, not 3. And actually, same thing for the last one. If I do 3 plus 4, I get 7. 3 minus 4, I either get 1 or negative 1. So this is actually a case where none of your combos work. What that means for us, it just means that this is my final answer. It just means that this leftover piece inside right here, it just means that none of that actually factors anymore. This part of it right here is what we call prime. It's kind of like if I were to ask you to factor the number 7. Factoring to the number 7, you're saying, well, what multiplies to give me 7? It's really just 1 and itself. All right. Now, I will say that we do not deal with a lot of examples like this. Most of the examples that we are going to deal with they're almost 95% of the time they're going to factor, especially with what we're going to do in some upcoming days where we solve by factoring. If we're solving, and we'll get to the solving aspect, but solving, that means it implies that it has to factor, okay? Now, the other 3 on this page, 5, 6, and 7, we are actually going to do those in class. If you would like to give them a shot, I'm going to pause your video now and I'm going to write the answers in. Okay, answers for those are up. So if you would like to give those a shot, please go ahead and do so. But there is one thing that I'd like to make you aware of for number 6, just as kind of a precaution. Just keep in mind whenever you're solving, kind of like when we've always pull out a GCF, one thing to always know about factoring is that if there is a leading negative, like there is when we say before the x squared term, we always factor leading negatives out in the GCF. So like as a hint on number 6, GCF wise, there is no number that goes into both 1, 12, and 36, but because there is a negative in front, that means a negative 1 is what we have to divide out, okay? Now, there is another method of factoring, and this method actually also works if you want on any problem that I throw at you. So especially if guess and check is not necessarily your favorite, grouping is a method that works out really nicely. And it's usually, we always use this when the A value does not equal 1. So when it's something, 1 or negative 1. So when it's something kind of more complicated. because guess and check actually, I think guess and check becomes more complicated on a problem like this when that happens. So usually when we solve this by, or factor this, excuse me, by the grouping method, our first step is actually it's going to seem kind of odd, but we multiply the a and the c value. So just remember, when we look at any standard form of a quadratic, a just talks about the number that's in front of the x squared term, and c talks about kind of the number on the end. So we start by just multiplying those together. So for us, I'm going to do 5 times 6, and we're going to get 30. So step 2 is kind of similar to guess and check. Our question that we have to answer is we have to find a number that multiplies to be 30 and adds to still be the middle number. Okay, so usually, again, this is where I usually will go through, and I'm gonna find all my factors of 30. So factors of 30, there's really only 3 pairs. It could really be 1 and 30. It could be 2 and 15, or it could be 3 and 10. All right, now, the number that multiplies to be 30 that also adds to be 17, well, the only option that would work here for us is 2 and 15. So when step 3, this is what we call the rewrite step. Okay, so this is where we actually start to get into the actual factoring. What happens is the first term comes down, so the 5x squared is going to stay. The last term is going to come down, that's going to stay. So these basically come right exactly from the equations. All right, whoops, I just deleted it. All right, and then what number is going to go, what 2 things are going to go on the inside here. And these come from this right here. Basically 2 and 15, what they're going to do is they're going to replace the 17x. We're going to break it up into a 2x and a 15x. The magic numbers, we just don't use those in our parentheses. We use those to actually put in the problem. Now, when we solve by grouping, grouping happens whenever we have 4 terms. So in step number 4, we actually perform what's called the actual true grouping step. And that is where we group the first 2 terms and we group the second 2 terms. And what we do is we find a GCF. And really we treat them kind of like 2 separate problems. So we say, okay, GCF of these first 2 terms. Well, I have a 5x squared and a 2x. So GCF on those guys is an x. So if I divide both of those guys by x, the leftovers are going to go on the inside. So it had 2 x's, I'm taking 1 out. We're left with a 5x. Here, I took out an x, all that's left is a 2. And now we move on to the second set of parentheses. And we say, okay, same thing. What is my GCF between a 15x and a 6? Well, the highest number that goes into both of those is 3. So if I divide both of those by 3, we're going to be left with a 5x plus 2. And this is the step where you actually will be able to find out if you're correct or not so far. Because if you guys notice, if you look at what's inside, hopefully you'll notice that those are the same quantity. So what happens is this basically is outlining for you what your final answer is going to be. 5x plus 2 is going to be one of my factors. And the numbers that are outside become the second factor. Now, I don't know if you thought about this up above, but I wrote this in as a 2x and a 15x. A lot of students will ask, well, Ms. Hardy, what if I had flipped those? What if I had done plus 15x plus 2x? Fun fact, you actually still get the same exact answer at the very end. Your grouping steps might be a little bit different, but this should still happen. These 2 things should still end up being the same. And your final answer still ends up being 5x plus 2 times x plus 3. All right. So grouping method I know is a little bit longer, but the nice part is those steps literally never change. We always start, when we go through grouping, we start by multiplying a times c. We say, well, what number multiplies to give me that number that adds to give me the middle number? Then we do the rewrite step. Then we group, and then you're going to get your final answer. All right. So if you like using that method, really for all the methods, it works. And this is something I'll obviously go over a little bit more in depth, but now's the time where if you want to pause your video, you can give number 1 and number 2 a shot. All right, answers are up. Just as a reminder for something like number 2, if it helps, if ever you're missing a term, you are allowed to add that piece in. Usually if you're ever missing the middle term, adding in that middle term will help. All right, but I will be going through the examples that we didn't do in class. So obviously this is the point where if you do have any questions, feel free to email Ms. Hardy and we will find a time to meet. Thanks, guys.